Hello students, welcome to my channel. So we are following some schedule for this lesson, and last topic I have told about PN junction diode, and now we are going for Zener diode and some topics in the transistor. And I am going in the exam point of view only. Okay, so thank you for watching, and if you are not subscribing, please subscribe and watch the video so that it will be motivating for me. Thank you. So today's our topic is Zener diode. So PN junction diode and Zener diode. So what is the difference between these two? So PN junction diode, if you see, it's a lightly doped. We are doping some aluminum and silicon, so that with the silicon. So that is Zener diode we are doing actually heavily doped. And not only heavily doped, we have to give in that PN junction we use it for the both forward bias and reverse bias, but this diode we have to do because it's a special purpose diode, so we need to use a reverse bias. And now we need to do, because not only this one, in the reverse bias it's having some special property called breakdown voltage. That means in reverse bias, that Zener diode will come into the breakdown voltage condition. What is the breakdown voltage condition? Where the Zener voltage remains constant and the current through the Zener diode is increases. This is a condition for the Zener diode. And what is the purpose to use this one? It is used for the main voltage regulator. Okay, so this Zener diode I am taking, it is a normal PN junction diode only. Okay, and this one side I am giving P and N, so that you will get one depletion region, and this I have to give positive. I want to give reverse bias. Because of this reverse bias and heavily doped, the electric field becomes, because this is a depletion region, so that electric field will come in this one. So I am giving like this, the electric field will come like this. Inside this one, electric field will come in this. So this electric field will be more strong, too much strong, because of as we are increasing this reverse voltage. So when you keep on increasing this reverse voltage, and in this the electric field also becomes too strong. So how much it is strong now? That strong because of the high electric field. The bonds in this, that is because majority carriers, because of the reverse bias, majority carriers they can't give any current in this, because majority carriers are holes and electrons, they will be taken to the battery itself. So there is no chance of current because of the majority. The current is because of reverse bias, so it is because of minority charge carriers. So who is giving that minority charge carriers now? The electric field which is produced in this, it is very high electric field, and that electric field will break covalent bonds, because the covalent bonds contains some minority charge carriers. So this covalent bonds, once if it is broken, you will get holes and electrons. These holes and electrons, because of this electric field, they will be sending like this. Because of electrons and holes, because of electrons in this holes, because in this minority charge carriers are electrons, and in this minority charge carriers are holes, and this electric field is like this, and electrons will travel like this, and holes will travel like this. Okay, so these holes and electrons, they created in this P, in this electrons will create and these holes will create in the form of minority charge carriers, and these electrons will go in this direction and the holes will go in this, that is called drift current. Already we studied. So minority charge carriers will give you drift current in this the maximum amount of current will come. Okay, and now if you see the symbol of this one, This is normal diode and this is the Zener diode. is like a Z shape. Okay, and suppose in this if you take here PN junction, it is a heavily doped, and heavily doped. If you use lightly doped in the reverse bias, so reverse bias you will get less amount of current. So if you see the graph here, it will operate only under the reverse voltage. So until if you increase the reverse voltage, and you will get the reverse current. If you keep on increasing, so that a particular voltage will come called a breakdown voltage, where you will get the maximum abrupt change in current. So that this is you will get the minimum current, and this is you will get the maximum current within a very less voltage, because in that particular voltage the current goes from minimum to maximum. So that is called Zener breakdown voltage, because slowly will come and becomes abruptly maximum. So like this we can understand this Zener diode. Coming to the next topic, Zener diode as a voltage regulator. Especially problems purpose, this topic is very important. So voltage regulator, we need there are two types of regulations we can get. One is line regulation. What is line regulation? Input voltage. Actually any power supply we need always input and output. Okay, so this input coming from the power supply, it is variable, and output is, we should maintain it constant. Line regulation. And next one is load regulation. In this, input will be constant and output, that is in the presence of load, it will be variable. So some people will be confusion. What is load? So load only that fridge, TV, all this and all, these are all called loads. We will get the output from that. Okay. And so we will see now line regulation. But that is only important for us, because to maintain the constant output. I am taking now one resistance and one Zener diode like this. And this is unregulated DC voltage coming from the rectifier. Because rectifier only it will do only 81.2%. If it is a bridge rectifier, it will convert AC to DC, but in that DC also some fluctuations will be there. So that fluctuations also will be eliminated with help of this regulator. So it is regulating the fluctuations in the power supply. And one constant, one load resistance you have to take here. Now when it is coming in this, the current will come in this resistance. This resistance is called limiting resistance. So this limiting resistance, it is in a factor to arrange in such a way that always it should be, this terminals should have a constant voltage, because the Zener breakdown voltage will be having some VZ. So when the voltage comes across this VZ for this Zener diode, it will come into the region of breakdown. So until it comes into the breakdown region, this will help. Suppose if I am taking here 5 volts, I want to maintain 5 volts output, because both of them are parallel. When this is 5 volts, so to maintain 5 volts output, I want to take 5 volts breakdown region Zener diode. So when you maintain this 5 volts, automatically it will maintain like this. So to maintain constant 5 volts for the output, I need to select a power rated, otherwise I need to select a voltage rated of 5 volts Zener diode. Suppose in this 0 to 10 volts, suppose in this 7 volts is coming, that is VI should be greater than 5 volts suppose. So 7 volts is coming in this. Because of this limiting resistance, the 2 volts will stop in this and 5 volts only will come in this one. So because of this, because of this limiting resistance, the excess, how much it is needed. So which is helping for this one, limiting resistance only helping the Zener diode to get into the breakdown voltage. If you don't use this one, it will spoil because more power will be generated in this. More power will be generated in this. So that's why we need to use this one to protect this one and to get into the breakdown region. Okay, and that is in this. Suppose if it is used, you are getting 2 volts will be stopped in the limiting resistance. Suppose if you use 6 volts, 1 volt will be stopped in this 1 volt, and it is coming the 5 volts. So as the voltage is reducing, the current in the limiting resistance also will reduce, and the potential drop also will reduce. And it will not affect this one. It will not affect. It will not, because of this RS, main advantage only will be there, not disadvantage. Because the advantage is it will maintain the constant breakdown voltage for this resistance. And when the I is coming here, it will goes, current is divided, it's a parallel combination. So I is equal to IZ plus IL will come. When I is equal to IZ, by using Kirchhoff current law, the current is coming here and going current is this one. So sometimes they'll ask IZ, sometimes they'll ask I, okay, sometimes they'll ask IL. Coming to the next topic, transistor, a very important topic, transistor, which is not in NCERT but which is available in the NEET portion. So transistor, nothing but transfer of resistance. Transfer of resistance from where to where? From low resistance to high resistance. So what is the difference between diode and transistor? Actually diode is a 2-terminal device. Okay, 2-terminal. But here the transistor is a 3-terminal device. 3 terminals will be there. And how to create this, how to produce this transistor? In 1947 they created this one by Bardeen, all this one. Okay, for this I am taking now a PN junction, a normal diode. Okay, and in this, suppose in the same crystal, if I dope another material of P, so that I will get the 2 junctions now, 1 and 2, because in PN junction only one, in PN junction diode, in diode only one single junction, but now in transistor 2 junctions will be there. And if I take this one like this, if I create okay, NPN, that is NPN, like this, if we create one transistor, because PNP transistor, NPN transistor, like this if we create, I can use in a circuits. Actually where they will use all these transistors? In computers. So in the present computers also 20 lakhs or 10 lakhs transistors they'll use. So the transistors mainly they want signals, input signals. Even if you see here I'm using mic, that mic is also having some small transistor. It is giving my audio so that it will increase its strength of the signal, strength of my audio. So that is the transistor mainly used for the amplifier. So we can see some mic, one apparatus will be there, na? That mic set, they'll use some stereo, all these things, bass, terrible, and that in that transistor will be there. So they'll make into some proper arrangement called active region, where the proper input of a teacher, because some people will use mic in the classroom itself. So that one they'll use this type of transistors. Say I'm using a normal mic. Okay. So everywhere, if you want to produce a good strength and signal, we need to use one transistor. So transistor is mainly application is amplifier. Okay, we can use like a switch, on and off switch. We can use like a oscillator. Like oscillator, what is oscillator? DC to AC. Conversion of AC to DC rectifier. Now AC to DC. Now DC to AC oscillator. So transistor applications, it can be used for the amplifier, and we can use like a switch, and we can use like a oscillator. Okay, and now So in this PN junction, PN junction, two PN junctions I told na, and three terminals I told. That three terminals are called emitter, and B is called base, and which is in the middle of this one called base, and this is called collector. So what are three terminals now? First one is emitter, which is in left side. Okay, it may be NPN, here also emitter, base, collector. So emitter is first, we are doping all this in a single silicon crystal. Okay, not only two times we are doing with the same component we are doing here. Same phosphorus, aluminum. Like this we are doing. But here when we are doing this doping in this aluminum, that is phosphorus, we need to do heavily doped. So emitter should be heavily doped. And the size should be, we have to maintain moderate size. The size should be maintained, because PN junction will take exact half and half PN junction diode. But here you have to take slightly, we need to modify the diagram. So one size we need to take a moderate size. Next one is which is in the base. The base should be very thin. We need to use very lightly doped, and we need to use very small region for that one. So lightly doped and small region. And this one is collector, which is used to get the output current. So this one is, we need to give bigger size, and we need to take mediumly doped. Okay, so there are three components will be there for the transistor. One is emitter, base, collector, but they will not maintain like this equal size. They will maintain like this. That is NPN, emitter, base, collector. Collector should be bigger in size. Okay, this is in micrometers. That much small you have to maintain. Okay, transistors, already told some examples. And now these two junctions, again I am saying now the two junctions. Okay, we need to use two junctions, names are called, this is emitter, base, collector. So first junction is called emitter base junction. This junction is called emitter base junction. And next one is called base collector or collector base, because collector is more doped. So collector base junction, this junction. Okay, and to do the transistor working purpose, we need to use one biasing, like forward bias, reverse biasing is there now for diode. Here also we need to use emitter bias, should be emitter base. This junction should be forward bias, and this junction should be reverse bias. That is, this junction you have to maintain forward bias. This is also having some depletion region, and this is also having some depletion region. So in the terms of depletion region, if you want to see the diagram, depletion region N, and the depletion region is very small, NPN. Two types of transistors, PNP and PN. Two times P should be doped, two times N type should be doped. That's phosphorus. And in this, the depletion region should be very bigger, because it's a reverse bias. So in this forward bias and in this reverse bias. So in the forward bias is having low resistance. Forward bias, no low resistance, easily they can travel. Electrons can travel from N. Reverse bias, majority carriers they can't travel, only minority carriers. So that minority carrier, so it's having high resistance. So from low resistance to high resistance, I want to transfer my current. So current traveling device with respect to two junctions, that is low resistance to high resistance. That's why it is called transistor. So we need, it's a current making from one place to another place, that is from low resistance to high resistance. Okay, we'll see the posture now, that is symbol. So three is there, emitter, base, collector. If you see the presentation, it's a different presentation, but very easy only. The presentation is like this. This is called base, and two lines like this have to keep. So this is base, this is collector, this is emitter. I can use like this also. Base, like this I can use. Base, emitter, collector. Why I wrote emitter down? So because we need to use some mode of configuration, some mode of connections have to use in this, like CE mode, CB mode and CC mode. What is CBCC? Common emitter, common base, common collector. Like these three modes. In this is more important. This is also important, but this is we will not use regularly, because in this this is more important, we will see in the later topic. Okay, this is also more important. Okay, and now to give this one some arrow marks they prescribed, because just like that, if you show here, we need to show the current direction. I am drawing here B to E and here also B to E, and this is for the NPN transistor. NPN transistor symbol. The symbol of NPN transistor is this one. The symbol of transistor is this one. What is the difference between these two? This is called common base. This is called common emitter. Common emitter. What is common? We'll see all these things now. Okay. So if you continue, I'm showing this diagram. Still some people confusion will be there. Those are new to this topic. Okay. I'm going just a brief diagram of this one. Why I'm keeping the arrow marks, all these things. For that we need to use a working of NPN transistor. Why I am always using transistor NPN only? Because in NPN the majority carriers are electrons. Okay, PNP also can be used, no problem. But in the practical purpose in engineering, all these things, they'll use only the NPN transistor, which is having more advantages. Okay, and now I'm taking NPN transistor working. Detailed working, only exam point of view working I'm taking here. So this is NPN transistor, emitter, base, collector, emitter, medium size, base, very less size, collector. And this is NPN. In this electrons are more, as it's a heavily doped, and these holes are less lightly doped. Electrons are moderately, but they'll occupy the space because it's having bigger in size. As a concept, this junction should be having forward bias. So when I keep like this is called common base. This diagram represents like a common base because it's a common. And we can take this is called input. Input, because from here only electrons will start here. And this junction is forward bias. You see now negative, negative, positive, positive. And this is forward bias. And in this we need to take a reverse bias. Negative means connected to the positive. So, and this is reverse bias. And because of this forward bias, electrons will be pushed towards the next junction. That is towards this junction. They can cross this B, this base, and in between some holes are there. Okay, suppose 10 electrons are there. In the 10 electrons, suppose if they cross this junction, a few electrons or 2 to 3 electrons will combine with these holes. Okay, that means 2% of the electrons. Listen carefully. This is called forward bias, negative repulsive force. So 10 electrons started traveling. They can easily cross this junction because it's a forward bias. In that 2% will combine with the holes, and remaining 8%, that means 10 electrons started or 2 electrons combined with the holes and 8 electrons came in this one. The 8 electrons now, will be attracted towards this battery. Because once the electrons started, they should reach to the end point. So electrons started like this and they crossed this junction and they came and neutralized in this battery. Now we need to take, that means electrons are going like this. They started from repelling in this, they started like this. So emitter to base, the electrons started. For that opposite current you need to take, that is base to emitter. Because electrons they crossed like this, so that in this direction, forward direction, and we need to take the direction of current in opposite direction, that is like this. This is called emitter current because electrons are going like this in opposite direction. And now electrons are coming like this. Electrons are coming like this. So opposite direction. This is collector current. Collector also having some current because electrons are coming and in this one. And is coming and approaching this battery. And in this the base current, if you see here, the base current, the electrons, suppose some electrons will be there here. Some electrons, because majority holes say, minority electrons will be there na, minority electrons, and some covalent bonds will be there that will be broken. So that kind of no problem, but we need to know the direction of circuits, So electrons are coming like this, electrons are coming like this, and the opposite direction is like this. Electrons are coming like this, as the opposite direction. Electrons are coming like this, opposite direction. Electrons are going like this, opposite direction. Electrons are going like this, opposite direction. These are the arrow marks. And using Kirchhoff law, IE is equal to, how many currents are coming here? Two currents are coming, IB plus IC. So Kirchhoff law is maintained here. It's proved. Charge is conserved. So IE is equal to IB plus IC. Okay, this one I will show in the form of a normal circuit diagram. That is common base. It's a common base na? It's a common base. So common base because of this one. So like this, common base, and this is NPN transistor and emitter, base, collector, emitter, base, collector, and this is emitter, base, collector is which battery? Opposite, that is forward bias, opposite, same, N negative, P positive, N negative, P positive, and this is connected to the opposite, N is connected to the positive and this is connected to the negative because reverse bias. So like this we can show the diagrams, and base to arrow mark is, base to emitter is arrow mark. So this diagram same only. Okay, like this we can use common emitter also. Common emitter. For that again no need to do the explanation. I will draw the diagram. Common emitter configuration. So C, E, because I should shift like this because I need to take. In this part is called input, this part is called output. So if anything you need, we need to strengthen the signal. I already told now we need to strengthen the signal. For that we need to take the gain, current gain. So in this, what is a current gain? If you take alpha, current gain, always output by input, like transformer gain, efficiency of transformer, output, power by input power, like this. What is the current you will get in this? Output current IC, and input where you are giving input IE, input. So what is the current gain in this formula? Alpha is equal to IC by IE. And if you take here NPN, and now I want to draw like this diagram. So base and emitter. This is NPN transistor. Base and emitter. Base and emitter should be forward bias. Should be forward bias. Base and emitter forward bias. And collector and this one reverse bias. So base emitter. Base emitter. Base is positive. Positive. Like this. Base is positive. Positive. Emitter is negative. Next, collector is N. Collector is N. Opposite you have to give because next junction always left hand side is forward bias, right hand side is reverse bias. So left hand side is forward bias. P to P, N to N, negative to negative, positive to positive. And this is N. And this is base because collector base we want. Collector base, that is like this. You will get the same polarity of battery in this one. Now this current gain is called beta. For this, like this we can draw, and we will use all the circuits only this one. This is very important. And beta is nothing but here what is output? Where you are getting output? IC. Always output you will get in collector only. And input where you are giving input? Base. So IC by IB. So here you are giving input for the emitter, here input you are giving for the base. So IC by IE, IC by IB. Okay, we need to take some relation here. We will see in the next lecture.